So today we're at our newest brewery we just did, one of the most incredible breweries on the planet, Florida Ave Brewing Company. Anthony is who we worked with on that. And let's go inside and see what we have going on in there. It's very exciting. Come on in and we'll check it out. Okay. So now let's go ahead and go on inside the cooler. This is where the cold beer is stored. This is where all the equipment and the design happens to get the beer pouring. Now, it does say 40, but that's only because we've been going in and out a lot. It's normally at 36 or 37 on the. Come on in and let's take a look at what we have going on in here. So you can see this is where it happens. We've got the system set up. We've got the kegs. We've got them on racks so it's nice and neat and clean. And then we've got the regulators. We've got the gas coming into the coupler. That coupler down there. Then we've got the beer flowing out into our fob. This happens to be a Micromatic fob. And then we're going into a beer manifold. Now the reason we're using the beer manifold is because we're going 3 locations from one setup. You say, wow, that seems complicated. It is, but we'll talk about it, and it's just a mathematical formula that we use. You can see from the fobs here that when they drain a little bit, it goes into these overflow jugs right here, and that's so you can catch a little bit of the overflow. We've got everything numbered, crystal clear. You can see even on the couplers, they're numbered. So we number the coupler, we number the beer manifold, we number the fob. We don't want any confusion. So it works out really well when you have a well-organized machine. Then you have all the lines going up. You can see all those going out to the different locations. And then the glycol coming in. We don't need the glycol in here because it's cold in here. We've got the temperature right for the cooler, and then we blended the right gas to give us 2 ounces a second flow. Now we'll go outside and look at the tower, and we'll see how at 3 different locations we're able to get the same 2 ounces a second flow rate. And that's where the formula happens that helps you excel. It helps us excel to get the perfect pour with the perfect yield, 100% yield, and the gas blend and all that. So let's go ahead and look at a tower outside and see what we have going on out there. Alright, so now we have this tower. So this is a hanging 6-inch tower we made custom that Anthony loved. We drew it up on paper and he said, yeah, that's what I want. And so we had it custom made with the flanges. It's 6-inch and it's dual service. So on this we've got 1 through 16 on this side and left to right. So we always want to start left to right. So this is tang. And when we go over to the other side, that side's tang on the left side too. Then we've got the rinser drip trays. And you can see that way we can break the surface tension on the glass. Then we can pour a beer, and you can see we've got perfect 2 ounce a second pour here. We're going to get a perfectly yielded beer here. Nice amount of foam. And what's happening is that CO2 is releasing now in the glass. You can see it continuously flowing up, so while they're drinking it, it's going to be continuously releasing it. And we've got 2 ounce a second pour. So the interesting thing is there's 2 separate lines in here. This line is at 50 feet of length from the cooler, and this line is 60 feet of length from the cooler. And then we'll see in a moment when we go back, we have 200 feet of line, all pouring from the same setup inside the cooler. And you say, well, how do you do that? Well, we do the calculation to get the restriction we need. We decided that because we're 200 feet in the back, that gives us 20 pounds of restriction. The tower that we had specially designed is 7.5 pounds of restriction, gives us 27.5 pounds. Then we have some lift from the bottom of the keg up to the fob. So that's 5 feet, which gives us 1/2 foot per pound, which is 2.5 pounds. So 27.5 plus 2.5, we learned in 2nd grade, is 30 pounds. So we know now from our 2nd grade math lesson that we have to dispense at a minimum of 30 pounds to get it 200 feet from the back. from the cooler to the back tower, which we'll show in a minute. And then we'll blend the gas accordingly so we get the perfect 2.7 volumes of CO2. So in this case we used about a 59, 41% blend. CO2 always mentioned first. So we've got a 59% CO2 to a 41% nitrogen, which nitrogen molecule just pushes it through and doesn't ever join the beer. So we've restricted this side, 1 through 16 on this side, to get 30, a little more restriction. This side being 60 feet because it's a little bit farther away. We restricted a little bit less, but always so we have 30 pounds of restriction built in because that is our desired pour pressure. And then we blended our gas to be that blend that gives us the 2.7 volumes of CO2, which is perfect for what the brewer designed. Ales and lagers generally, as we've discussed and learned earlier, about 2.5 to 2.7 volumes of CO2 less for ales, about 2.5, 2.6 and a half, 2.7 for lagers. And that's what we've designed this system to flow perfectly. Okay, so we've got the trunk lines that are in the ceiling over here, and they run out of the cooler. And there's the 60 foot and the 50 foot up in that ceiling there. There's some lights on, but you can see it. They run straight across. The third one runs up in the ceiling in this chase right here, which we designed out of PVC, and it runs along the ceiling all the way out to the outside bar. And that's how we get that trunk line all the way out to this bar out here. And sometimes you can't go the most direct route. You just have to go on the route that you're able to, and that's how we ended up at 200 feet. Sometimes at the stadiums we might be 300, 400, and 500 feet. Now you're going to have a lot of waste when you clean the lines on that long of run, but what we do is we minimize the line size. This one we used 5/16 on all the lines, and that gives us the least amount of waste when we are line cleaning. So it works out pretty well for the customer. So now we're at the outside tower that we just were talking about, and you can see it wrapped around. It's 200 feet. Comes all through the building. Then we come out here. We've doubly wrapped it and supported it. And then we come down here to two sides because it's 16 beers, so we have 8 and 8. And I can feel these are cold because we're running 28-degree glycol through them. Then we go through the wall. This happened to be about a 2-foot wall that we had to core drill through. And then we've got the lines going into the back of the tower. That's how we get it. This is the behind the scenes. Then they have their drip tray goes into this little pump that then flows it out into the drain. And we're not really having much in that. So the key is that's a drip tray, not a pour tray. So we've got hardly anything. So let's go outside and take a look at that tower out there. So here we have this tower was already at 30 pounds of restriction, and this is what determined the actual pressure we could dispense at, because by the time we calculated the 200 feet of run, the 7.5 pounds built into this tower that we made custom, and the lift from the cooler, it was 30 psi. So that tells us, okay, we have to be 30 psi to flow 2 ounces a second here. Now we have to make everything else that's closer and shorter runs flow at 2 ounces a second, so we still restrict them to 30 psi with our proprietary restriction process. And it works really well. And now we have 2 ounces a second out here, ice cold, and 2 ounces a second inside, and they've got a perfect pour. They've got almost no waste ever. And that's the name of the game, because their product is precious. So your product, like Anthony's product, you don't want to have any waste. You want to be pouring beautiful. So at your brewery, you want to make sure that you design your system, or you work with someone that's an expert that really can get you that perfect pour and that 100% yield at the pour. Of course, you'll always have a little waste at line cleaning, but you have to clean lines because you want the cleanest lines you can. And then that comes to using the right product so that you have the best lines so that they don't get built up on them very easily. So here we've got a rinse or drip tray. Remember, it's just a drip tray. It's just to catch drippings, not to be pouring into, because on a perfect pour system, you're not going to have hardly any waste at all. So we've got the rinsers built in, And then we've got the 16 product tower. We made it custom. Anthony just wanted it hanging off the brick wall. We built this little shelf for him, and then we put the rinser drip tray right on it. So again, I'm going to rinse this glass. I'm going to pour us a little beer. I'm going to go sideways here. Okay, and this particular beer is not on because we did a little maintenance. So let's get this beer right here. There we go. We got a nice pour. And this is a sample, and look at that. Even into a small glass, we've got a beautiful little sample there. Lovely. That is an incredibly delicious Florida Ave Brewing beer, which is wonderful. You can see it's got a real nice pour. This could go to the customer as a sample, and they would be real happy. A lot of systems, when you pour a small glass, you don't get a perfect pour because it pours too fast. But we've got this right at 2 ounces a second, and we're getting a really nice little pour there. Every time, see that CO2 release in the glass? That's what we're really looking for. We don't want to releasing before it gets into the glass. Now as the customer is drinking it, we can see there's still CO2 releasing, and that's going to be releasing the entire time that they're drinking that beer. Okay. So we want to just show you this on this drip tray. We want to make sure that it either has an X brake, which are lines in it to flow down to the center, but if it doesn't have an X brake, you want to make sure that the outer edges are a little bit higher so you're up, so that when you do have beer flowing in there in water, you can see it's flowing right to the drain, because you don't want any. You can see we're already dry up in the corners. And that's the key to excellence, is paying attention to the details. Every detail is essential and critical in obtaining an excellent system. So we're real happy with this, and we designed it so that it would flow. And this is actually a custom shelf we made to put this drip tray. It just hangs on the back of the wall, and then it has the water running to it. We made this skirt right here, so it looks really nice. Anthony really wanted it to be as nice as possible. Okay. So now we're underneath. You got me underneath here, and we've got the rinser lines. They run right here to this rinser, and then it goes to the other rinser, and then we've got the drain line. So you can see that when we're flowing, and I'll go ahead and put some water in the rinser, and you can see we'll get that drain flowing. We want to make sure that our drain's flowing, so we're never filling our drip tray. Now you can see we've got water flowing, and it works really well. We're flowing fast, and this drip tray is draining quickly. Another thing about having the rinser, it keeps the drip tray clean, because you're always rinsing fresh water through there. Alright, so here is the third and final tower at Brewbus. This is a custom tower made for a keg box, so it's a little bit different, but it's still custom because Anthony's very particular and he wanted everything perfect. So we made him this to match all his other towers. This actually matches the hanging tower and the wall tower in the same product we used. Now it's a keg box, and he's using only plastic cups, so we don't have to have a rinser because you don't rinse plastic cups. But you can see, as it being a keg box, it's just a direct draw box. We're direct drawing there, we're coming up into here, and we're pouring. So you can do a custom tower on a keg box. We did his drip tray for him. We built this little shelf to make it really match and fit in nice. And then we drilled through the countertop, through the keg box, and now we're able to have a super custom looking product. This is also a Micromatic tower. All three were Micromatic towers. We have Micromatic build the tower for us once we design it. And they have the equipment to cut and weld and polish for us. And that's the name of the game, is we're designing it, and then we have other people that are able to do the muscle work just to build it and put it together. We don't need to buy lots of equipment. We just need to have the knowledge of how to design the best system. And this system works really well. It's been very successful for Anthony. See, this box has its own CO2 supply because we didn't run a line all the way from the front of the building. And this one is set right at 12 psi. You can see it. We used a lower pressure regulator so that we could be able to see the pressure that it's set at. So we're dispensing at sea level, same 2.7 volumes of CO2 that he's got here. And we're at 13 psi at sea level with a 36-degree box. Will help us maintain inside the box that same 2.6 or 2.7 volumes. It's right in that ballpark. We're not going to be 100% perfect, but excellent. And excellence overcomes perfection, because you'll never attain perfection. But excellence gives him his beers that are perfectly carbonated, pour really well, and are fresh. And that's the key. So this is his party room, and we're only using plastic cups, and this is the drip tray, and set up and built it all from scratch. So we're real excited about how this turned out.